In this chapter, we will learn about surface area of solids, volume of solids, surface area of solid figures, connection between plane figures and solid figures. Solid figures can be formed using plane figures. In the animation, we have shown how a cuboid can be formed from a rectangle. First, place a rectangular sheet. Now go on adding rectangular sheets one above the other. And in the end of this process, we get a cuboid. Similarly, a cylinder can be formed by placing circular discs one above the other vertically. Let us start with the cuboid. It is a solid bounded by 6 rectangular faces such that any opposite rectangles are parallel and congruent. For example, a rectangular brick, a matchbox, a water tub, a swimming pool. A cuboid has 12 edges and 3 pairs of parallel faces. These adjoining faces are mutually perpendicular and meet at a point called a vertex. A cuboid has 8 vertices. Surface area of cuboid. The outer surface of a cuboid is made up of 6 rectangles. As shown in the animation, the surface area of the cuboid is equal to the sum of the area of 6 rectangles, which is equal to twice of LB plus BH plus HL, where H is the height, L is the length, and B is the breadth of the cuboid. Lateral surface area of cuboid. Suppose out of the 6 faces of a cuboid, we only find the sum of the area of the 4 faces, leaving the bottom and top faces. In such a case, the area of the 4 faces is called lateral surface area of the cuboid. Therefore, lateral surface area of the cuboid is 2LH plus 2BH is equal to twice of L plus B into H, where L is the length, B is the breadth, and H is the height of the cuboid. Let us understand the lateral surface area with the help of this animation. In the animation, when the top and bottom faces of a cuboid are removed, then the remaining surface area is the lateral surface area. In this example, let us find the surface area of a cuboid whose length, width, and height are 10 cm, 15 cm, and 25 cm respectively. Solution. As we know that the surface area of a cuboid is twice of LB plus BH plus HL, where L, B, and H are length, breadth, and height edges of the cuboid respectively. On putting the values of L, B, H and calculating them, we get surface area of a cuboid is 1550 square centimeters. Cube. A cuboid whose length, breadth, and height are all equal is called a cube. Dice, ice cubes, sugar cubes, etc. are all examples of a cube. Each edge of a cube is called its side. The side or edge of the cube is denoted by letter symbol A. In the animation, we have shown that when a cube is disassembled, it gives 6 square pieces. Surface area of cube. If each edge of the cube is A, then the surface area of the cube is 6 times A square. Lateral surface area of cube. Suppose out of the 6 faces of a cube, we only find the sum of the area of the 4 faces, leaving the bottom and top faces, then the area of these 4 faces is called the lateral surface area of the cube. Lateral surface area of a cube of side A is equal to 4 times of A square. Now let us find the surface area of a cube whose edge is 11 cm. Solution. We know that the surface area of a cube is equal to 6 times edge square. Here edge is equal to 11 cm. Therefore, surface area of the given cube is 726 square centimeter. Cylinder. Solids like measuring jars, circular pillars, circular pipes, road rollers, etc. are said to have a cylindrical shape. A solid generated by the revolution of rectangle about one of its sides is called circular cylinder. In the animation, the rectangle ABCD, if AB is taken as the axis of revolution and revolved on it, then so formed solid is a cylinder. Surface area of cylinder. Curved surface area of the cylinder, which is equal to area of the rectangular sheet, which is equal to length multiplied by breadth, which is the perimeter of the base of the cylinder multiplied by h, is equal to 2 pi r multiplied by h. Therefore, curved surface area of a cylinder is 2 pi r h, where r is the radius of the base of the cylinder and h is the height of the cylinder. If the top and bottom of the cylinder are also to be covered, then we need two circles, in fact circular regions, each of radius r, and thus having an area of pi r square, each giving us the total surface area as 2 pi r h plus 2 pi r square is equal to 2 pi r plus h. Therefore, the total surface area of a cylinder is 2 pi r plus h, where h is the height of the cylinder and r is its radius. Hollow cylinder. Solids like iron pipes, rubber tubes, etc. are in the shape of hollow cylinders. Thus, we can define a hollow cylinder as a solid bounded by two coaxial, same axis cylinders of the same height and different radii is called a hollow cylinder. Surface area of a hollow cylinder. Let r and small r be the external and internal radii of a hollow cylinder and h be its height. Then we have the following formulae. First, each base surface area of a hollow cylinder, pi r square minus small r square, square units. Second, curved lateral surface area of a hollow cylinder, which is equal to external surface area plus internal surface area, which is 2 pi r h plus 2 pi r h is equal to 2 pi h capital R plus small r square units. Third, total surface area of a hollow cylinder, 2 pi capital R small h plus 2 pi small r small h plus 2 pi capital R square minus small r square, which is equal to 2 pi small h capital R plus small r plus 2 pi capital R plus small r capital R minus small r, which is equal to 2 pi capital R plus small r h plus capital R minus small r square units. Right circular cone. A cone has a curved surface with a vertex and a circular base. If the line joining the vertex and the center of the base is perpendicular, it is called a right circular cone. For example, a cone of ice cream. Height. The length of the segment OV in the animation is called the height of the cone and is usually denoted by h. Slant height. The distance of the vertex from any point on the base circle is called the slant height of the cone and is denoted by L. Generator. A cone is generated by revolving the slant height segment VA shown in the animation about the height. The line segment VA or the slant height is called a generator. Sphere. Objects like football, volleyball, throwball, etc. are said to have the shape of a sphere. The solid generated by revolving a circle about any of its diameter is called a sphere. The center and radius of this circle is called the center and the radius of the sphere. The fixed point is called the center of the sphere and the constant distance is called its radius. Surface area of a sphere. The curved surface area and the total surface area of the sphere are equal. Curved surface area or lateral surface area is total surface area, which is equal to 4 pi r square. Hemisphere. A plane through the center of a sphere divides the sphere into two equal parts. Each part is called a hemisphere. The curved surface area of a hemisphere is CSA or LSA is equal to twice of pi r square. The total surface area of a hemisphere is TSA, which is equal to 3 times of pi r square. For example, the radius of a hemispherical balloon increases from 7 cm to 14 cm as air is being pumped into it. Find the ratio of the surface areas of the balloons in the two cases. Solution. Let S1 and S2 be the surface areas of the hemispherical balloons when radii are 7 cm and 14 cm respectively. Then S1 is 3 times pi 7 square and S2 is 3 times pi 14 square. Then the ratio between S1 and S2 is 1:4.